something is peer-reviewed, does it mean it's a good article?
So peer review is a process that helps articles get better, but it's no guarantee that the article is a good article. There are plenty of peer-reviewed articles that are subsequently taken back, so you have to be very careful to not trust that that's kind of like the whole of the research just because there's some peer review article. At the same time, that process is important to understand that with peer review, you're getting other people in the field to look at what that researcher has done. So what it does mean is that other scientists have looked at the work and signed off on it, but it doesn't mean that the whole work itself is bulletproof. And a lot of times we see mistakes even in peer-reviewed articles, and sometimes they're actually retracted.
Okay. So if I also want to find out if a particular journal is a relatively good source or good journal or not so good of a journal, how do I do so, and can you tell me what the Science Citation Index is all about?
Yeah, so the Science Citation Index is a kind of a calculation about how many times other people have cited that journal, articles that are appearing in that journal. So if you have a high citation index, then that means that other people are respecting that work and referring to it. So it's a way in which we can measure essentially how much other scientists are looking to that journal to produce high quality work, and generally the better journals are getting higher citation indices. But it does matter if that journal has been around for a long time. So if you have a recent journal, it might not have a high citation index, but it doesn't necessarily mean it's not good research. So, sometimes you'll have really excellent research published in a less prestigious journal, or not such great research published in a high prestigious journal. And so it's not really kind of like a be-all and end-all, but it definitely can tell you that if you're published in such and such journal, you could look up the citation index, see how it's ranked compared to other journals, and get some sense of where that journal is standing.
Okay. So I heard somebody told me that in children under 10, height is correlated with reading skills. So does that mean if my kid is taller, he's going to be a better reader?
Right. So this is kind of a playful example to show how it is that something can correlate without being actually causal. So if you look at not kids who are all 10 years old and all 9-year-old children, but rather grouping together children who are 5 to 10 years old, they're growing at that age, and at the same time their reading skills are improving. So there's no reason to believe that as they're getting taller, they're getting better at reading because they're taller. And there's no reason to believe that, say, among 9-year-olds, short kids are having more trouble with reading than tall kids. But what you are seeing is a really great correlation between this height and this age, because they're learning to read, and they're getting taller, but there's no causal suspicion even. There's no mechanism to think why it is that being taller would be better. We just know we're just getting older.
Okay, but I also did hear that Nobel Prize winners is correlated with eating chocolate.
Yeah.
And so that will get smarter if I eat chocolate, right?
So if, there is some evidence that chocolate has contents that will help our cognitive abilities, but I'd say that that evidence is fairly weak, and what we're really seeing there is that chocolate is consumed in countries that have a lot of scientific research, and it's very popular in Europe, where a lot of Nobel laureates are coming from. So what we're seeing there is another example of something that is correlative. In fact, they'd never even looked at what the actual Nobel Prize researchers were eating, so we don't actually know that. But the suspicion is that this is a spurious relationship as well.
Okay. Now, tell me a little bit about significance. I hear a study, a clinical trial is significant. What's it mean if it's statistically significant, and what's it mean if it's clinically significant, and how are those different?
Right. So statistical significance is a measurement that is purely based on how many people participated in the study and how the data came out in terms of whether one group did better than another group. For example, if you're comparing medicine A and medicine B, and you put two different groups of people, one on medicine A and one on medicine B, and you say, well, which group did better? And you see that B did better than A, and then you start to say, say, well, is that something that just by chance would be very unlikely to occur if you were just doing it like you randomly assigned them and the medicine had no impact at all? And that's something you can calculate using statistics, and that's your p-value. So if you have a small p-value, you're saying, this group is unlikely to be so much better than this other group if we were just randomly doing everything and there were no benefit to medicine B. So that's statistical significance. It's just a statistical calculation that's telling us that one group is unlikely to do so much better than another if everything were random. On the other hand, clinical significance is something that actually is going to impact people's lives. So having a better medicine might be something that impacts someone's life, but if you're talking about, say, migraines and group B did do better than group A, but barely better, just like a teeny little bit better, even if it's statistically significant, it may not have a clinical use in terms of significance. Or other times we might say that you're measuring something that we don't know what to do with the measurement when you're done. If you say, I'm measuring the distance from this part of our body to this other part of the body, and seeing that gets elongated when you get some exposure to a toxin, and you start to say, well, does that really matter? Or is this, yes, it's an impact, but it's not actually going to have clinical significance. It's not going to matter for how people live their lives or for matter for decisions that we make.
Okay, I think that's all I need. Thank you very much.
Okay, great. Thank you.